right. Can we simplify 24 over 36? How? So pull out a 12 from each, and I get 2/3. Why does that work? So lots of explanations. Here's the one I'm going to focus on today. If I factor 24, 4 times 6, which breaks down into 2 times 2 times 2 times 3, right? 36 breaks down into 6 and 6, which is 2 times 2 times 3 times 3. Would you agree that all three of these fractions are the same? Okay. Now, what is 2 divided by 2? 1, and 1 times anything is 1, so I can cross those off. Anything else? Another set of 2's and a set of 3's, and I'm left with 2/3. And it just so happens the stuff I took out is equivalent to 2 times 2 times 3 is 12. Right? 2 times 2 is 4 times 3 is 12, so essentially I got rid of a 12. That's how fraction simplification works. If something shows up in the numerator and in the denominator, it can divide out to be 1. Okay? Well, what if I had 12 over 15, well, 12x to the third y z to the 8th over 15x to the fifth y z? We could do negatives, but we're not going to today. So, are there any numbers that come out? A 3. So, the 12 and the 15 would simplify down to be 4/5. If I were to line up 3 x's on top and 5 x's on bottom and start crossing them off, how many would be left? 2 in the denominator. So, x squared down here. Okay? The y's just cancel and they're gone. And the z's, there would be z to the 5th or 7th, z to the 7th on top. That makes sense, right? So that'll take you all the way through number 6. Look at number 7. Number 7 has 2 binomials. And I know this is going to be tempting, but you're not allowed to do it. You can't say, oh, r and r cancel, and 2 goes into 4 twice. That doesn't work. So let me show you something. If I had 4 plus 3 over 6 plus 3, can I cancel the 3's and say that's 2/3? And my answer is 2 over 3? No, because 4 plus 3 is 7, and 6 plus 3 is 9, which is nothing like 2/3. So, when you look at 4 plus 3 and 6 plus 3, you have to treat this as a single number. What if I had 4 plus 2 over 6 plus 4? Can I turn 4 plus 2 into a multiplication problem instead of an addition problem? Can I factor something out? I can pull out a 2, and if I take out a 2, what's left? 2 plus 1. And on bottom, I can pull out a 2, and I'm left with 3 plus 2. Now does anything cancel? The 2's cancel, and if I added those, I'd get 3/5. Now up here, 4 plus 2 is 6, 6 plus 4 is 10. Does 10/6 equal 3/5? Yes. So if you're looking at a binomial or a trinomial, you have to factor it in order to cancel. You cannot cancel any portion of a polynomial until you switch it into a multiplication problem. So in number 7, does the numerator factor? I can pull out a 2. So 2 times r minus 2 over r minus 2. Does anything cancel? R minus 2 cancels. Not the r and the 2, the r minus 2. It's like saying 2a over a. where a is r minus 2. So we can cancel that, and the answer is 2. Okay? So, number 9, does the top factor? No. So x minus 4 over, what about the denominator? Pull out a 3x. What's left? X minus 4. The x minus 4's cancel, and I get 1 over 3x. Does that make sense? Good. So number 8. No, it doesn't matter. So does the top factor? No, well, we could write 3 times 3 times 5, but you don't need to. Does the denominator factor? So 45 over 10 times a minus 1. Does anything simplify? Well, 5 goes into both of those. So that'd be 9 and 2. Now, if I had... hold on a second. If I had 90 over 100. So 90 is 2 times 3 times 3 times 5. And 100 is 2 times 2 times 5 times 5. What cancels? The 2's and the 5's. Would I leave my answer as 3 times 3 over 2 times 5? No. The answer is actually 9/10. We have to put it back together, right? So we break it apart to see if anything divides out, and then we have to put it back together. So over here, I have 9 over 2 times a minus 1. Can I leave it like that? No, it needs to be put back together. So this 2 needs to go in. So 9 over 2a minus 2. So you break it apart, check for common factors, divide them out, and then put it back together. All right, turn the page. What about number 15? These are trinomials, so we factor into 2 sets of binomials. So for the numerator, I'm going to draw the box, x squared and 12. Multiply those together, 12x squared. Are there factors of 12x that add to be 8? So 6x and 2x, x, 6, and 2. So the numerator becomes x plus 2 times x plus 6. For the denominator, I need to draw a new box, x squared and negative 18. Multiply those together, negative 18x squared. Are there factors of negative 18 that add to be 3? 6 and negative 3. So 6x and negative 3x, x plus 6 minus 3. So x plus 6 and x minus 3. Does anything divide out? The x plus 6's do. So my answer is x plus 2 over x plus 3. And a lot of you want to cancel the x's, but you can't. You can only cancel polynomials in their entirety, or their factors in their entirety. So you can't get rid of just the x's in this case. You have to leave it as x plus 2 over x plus 3. Because if you think about it, if x equals 1, is 1 plus 2 over 1 plus 3 the same as 2/3? No. If you add them, it's actually 3/4, which is not the same as 2/3. Okay? This is only half of the assignment. So don't hand this in when you're done. Tomorrow you'll get the second half, and you'll use these problems to look at their graphs and figure out what happens when you cancel things. So when you get done, don't hand this in, but I'll give you the answers for today, and then tomorrow we'll do the second half of the assignment. Okay? Good luck.